So intermolecular force, as the name indicates, inter means between the molecules. Inter means between the molecules. के between the molecule means के let's suppose you have water, okay, in the form of liquid. So liquid के molecules are attracted with each other in this manner. As you can see, okay, they are attracted together. Okay, this dotted lines are going to represent intermolecular force. The force which is going to attach the two molecules together. Of course, this force of attraction is a weak force as compared to ionic bond, as compared to metallic bond, as compared to covalent bond. तो उनसे तो काफी वीक होती है ये, लेकिन of course हमें इसमें भी डिसाइड करना है कि which one is a stronger intermolecular force and which one is the weaker intermolecular force. Okay, so intermolecular forces are absent in this. Like diamond, there is no intermolecular force. In silica, there is no intermolecular force. In ionic, there is no intermolecular force. In metallic, there is no intermolecular force. But in covalent bond, in
So they just
graphite,
have covalent bonds, right?
yeah, in covalent bond, there would be intermolecular force. In a graphite, there would be intermolecular force. Okay. So if you are going to
Sir,
discuss the type of
doesn't everything have intermolecular forces?
Sir,
int- Mhm.
no, you go on, please.
Okay, so there are three types of intermolecular force of attraction. Number one, we have permanent dipole. Number two, we have hydrogen bonding. And number three, we have temporary dipole, which is also known as induced dipole or ID force, or you can say dispersion force, van der Waals force, or it's also known as London force, or this is also known as London force. Okay, London force. So let's start with permanent dipole interaction. As you know that hydrogen chloride is a covalent bond, but this is a polar covalent bond. How we can identify whether the bond is polar or non-polar? ये तो बहुत ही आसान है कि polar means when you can see the different elements. Like hydrogen is different and chlorine is different. When you can see the different elements, the covalent bond which is formed by between the two different elements is a polar covalent bond. When you can see the covalent bond is formed between the two same elements or similar elements. Like what do you mean by same or similar? I'm talking about the electronegativity. आपको पता है कि chlorine Cl2 is the covalent bond which is formed between the two chlorine atoms. Electronegativity for chlorine is 3.0. Okay, so they have the same electronegativity. So this chlorine is 100% non-polar. This is 100% non-polar. Okay. And also you can see this is bromine molecule which is formed between the two bromine atoms having the same electronegativity. They have the same ability to pull electrons towards itself. So no one has no charge. It's completely non-polar. There is no charge on this bromine. But if
Sir,
you
मेरे
have
पास
this
क्वेश्चन है.
बोलो.
Sir, remember आपने बोला था कि um, uh, diamonds, all these things don't have intermolecular forces, right?
हम्म,
तो कैसे? How do they not have intermolecular forces?
देखो, in ionic bonding there is no concept of molecule. They are compounds. First of all, okay, they are compounds. They have electrostatic force of attraction. If you remember, कि जब हम सोडियम क्लोराइड फॉर्म कर रहे होते थे, सो वी यूज टू form sodium positive ion and chlorine chloride negative ion. After the
जी
formation of these oppositely charged ions, तो फिर वो attract हो जाते थे through electrostatic force of attraction, और of course ionic bond जो है ना वो बन जाता था. So वो that force is something else that is known as electrostatic force of attraction. We are talking about intermolecular force. The term molecule, remember, the term molecule is specific for the covalent bond. So that's the reason I'm saying कि ये सिर्फ attraction जो है वो covalent bond में होती है. Okay?
ओके
Yes. So इसलिए we would be studying the covalent, you can say the compounds. So let's suppose this is your HCl. Hydrogen is less electronegative. Chlorine is more electronegative. So due to the high electronegativity of this chlorine, electronegativity means ability of an atom to attract electrons towards itself. Ability of an element to attract electrons towards itself. So electronegativity for chlorine is higher. तो ये क्या करेगा? सारे electrons it would be attracting towards itself. As a result, chlorine would have partial negative charge. Due to the difference in electronegativity, HCl becomes polar. Whenever you can see the different elements having the different electronegativities, so you will say that the compound is polar. And another thing is that in polar covalent bond, you will see unequal distribution of electron. This is very important term that you are supposed to memorize. In polar molecule, there would be unequal distribution of electron. Remember, in polar in polar molecule, there is
सर वाज इट अनसिमेट्रिकल आल्सो
same, yeah, unequal distribution of electron, or you can say unsymmetrical. Okay. So due to this unequal distribution, so if you have hydrogen chloride, okay, so how many electrons are there? How many electrons are there in outer shell of chlorine? Okay, how many electrons are there in outer shell of chlorine? 7. And in an outer shell of hydrogen, you will say only 1 electron. Okay, so chlorine has more electrons as compared to this hydrogen. Chlorine has greater
So
number
sir,
of
is
electrons.
that why it's more electronegative?
हाँ, that's the reason कि chlorine is going to have partial negative charge. और दूसरा ये कि of course chlorine would be attracting the electrons of hydrogen as well due to the higher electronegativity. Let's suppose this dot is an electron of chlorine and this cross is for hydrogen. So these two electrons are more towards this chlorine due to the higher electronegativity. So that's the reason. So chlorine would be having negative charge. So the polarity induced, you can say, okay, due to the difference in electronegativity. So if you have a compound or a
Sir,
molecule in which you can see the same
So can
elements,
you repeat the further induce thing?
like मेरा कहने का मतलब ये है कि you have HBr, okay, HBr. Now I have to see is this polar or non-polar. Electronegativity values are given. Okay, so this is 2.1 and this is around 2.8. So as you know that bromine is more electronegative. So bromine would be attracting the electrons of hydrogen as well. So due to the difference in these electronegativities, okay, so bromine becomes partial negative. It becomes partial negative due to the higher electronegativity. Due to the lower electronegativity, becomes partial positive. It becomes partial positive, remember. Okay?
Sir, to
So
be
you
more
have to see,
electronegative, you have to be on the right side of the periodic table, right? And you have to have a smaller atomic radius and a greater charge, nuclear charge, right?
yes,
Okay, and sir, permanent dipole interactions occur between only polar molecules, right?
yes.
Okay.
And also in group 7, electronegativity decreases down the group. Fluorine is more electronegative, chlorine is less, then bromine is the least one, then iodine is the least one. So as the difference in electronegativity decreases, so it becomes less polar. Like I mean to say, I want to compare the two compounds, that is HCl and HBr, HCl and HBr. Okay, so this is 2.1 and 3.0. This is 2.1 and 2.8. Since the difference in electronegativities between these two elements is higher, so it's more polar. And the difference in electronegativities is lower, so it's less polar. It's less polar. Okay.
Do we also mention like the radius and the attraction of the electrons to like the atom
But they
when
would
we
give you
explain?
electronegativity. So no need to
Oh,
mention atomic radius
Sir,
or charges.
the
But
bigger difference, the bigger
so,
difference shows us that it's more electronegative, right? The
mm,
bigger the
no,
difference,
no.
right? Okay.
So bigger difference is going to show okay how polar they are.
Okay.
How polar they are. Okay.
Mhm.
Sir,
Or
when
why
you
this
said
is
in,
permanent? Hmm.
sir, when you said induced, does it mean that hydrogen is giving electrons to the more electronegative species?
Yes, exactly. Hydrogen is going to give away electron. क्यों? कि chlorine is more electronegative. It's going to take away electron from hydrogen. So that's the reason polarity generate due to the difference in electronegativity, or you can say they are different elements. Hydrogen is different and chlorine is different. And this
Sir,
is
can you explain
permanent.
how to induce?
कुछ भी नहीं है बस वो सिंपल इलेक्ट्रोनेगेटिविटी का डिफरेंस है इस वजह से. Nothing is new. Okay. कोई nothing is special.
Okay.
They are polar
वो बस
simple. Why they are
इलेक्ट्रॉन
polar?
क्लाउड
Why they are polar? Due to the difference in electronegativity. Why they are polar? They are having the different elements. They have the different capacity to attract electrons. That's the reason chlorine becomes partial negative and it is partial positive. So overall, we can say this is polar. Okay. Overall, we can say this is polar. Okay. Okay. Why this is called permanent? Why this is called permanent? Permanent dipole is the one in which you can see when the elements are different. So 24 hours this is polar. I cannot say that right away this is polar, but after some time it becomes non-polar. No. When you will be studying the temporary dipole, then you will be able to know okay what is the difference between temporary and permanent dipole. Okay. So let me tell you first that what is temporary dipole. So you can see okay temporary dipole means uh, hmm, okay see this temporary dipole.
Sir, temporary dipole occur between non-polar molecules, right?
Yeah,
Okay.
temporary dipole. Temporary dipole. Okay. So temporary dipole is present between non-polar molecule and it's weaker than permanent. And it's weaker than permanent. It's weaker than permanent, remember. Okay. And this is also known as induced dipole. ID force, induced dipole. How it works, let me tell you. Okay, I have
Sure.
this chlorine. Okay, yeah, bolo.
Sure, it's induced because the electron densities go to the opposite sides, right? Because of the repulsion.
Yes, this is
Okay.
chlorine, Cl and Cl. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is one molecule of chlorine, and this is another molecule of chlorine. Okay, this is another molecule of chlorine. Okay, now they are individual. They are individual, so I can say they are non-polar. This is non-polar, or this is non-polar. Okay, but when they are going to approach each other just like that, when they come close to each other, when they come close to each other, as a result of repulsion, these electrons are going to repel each other. These electrons are going to repel each other. These electrons are going to repel each other. So as a result of repulsion, after repulsion, what I would see, as you can see, after the repulsion, these electrons will be on the left hand side and these electrons will be on the right hand side. Of course, due to the repulsion, they are coming back. Due to the repulsion, they are coming back. Due to the repulsion, they are coming back. You know, due to this unequal distribution, before, when they were individual, when they were alone, so there were equal distribution of electrons, 7 7 7 7, before coming close to each other. But after but after now you can see there is unequal distribution of electron. There is unequal distribution of electrons. So yes, due to this, it becomes partial negative and it becomes partial positive. It becomes partial negative, it becomes partial positive. So इसलिए
Now,
मैं
what
कह रहा
about
हूँ,
the chlorine molecule are on our right? What about the atoms on that molecule?
of
Aren't they
course
supposed
they are
to
having the less number of electrons. They are having the less number of electrons. So that's the reason I will say that this would be partial positive, partial negative, partial positive and partial negative. यानी कि the side in which you can see the more number of electron, whether you have one more electron, two or three or four or five, whether you have one or more electron. So I would say okay, due to the higher number of electron, greater number of electron, that would be bearing a partial negative charge. And remember, whenever you are going to close them together, at that time they would be behaving like a polar molecule. But when you are going to when you're going to do this like that, so they will come to their original position. They will come to their original position. This is very important question. This is very important question. Remember, okay? It depends on how they close to each other. That's the reason I was saying that this is a temporary dipole. जब तक ये जब तक they are come close to each other, uh, so I will say that they are polar. But when they are going away from each other, so I would say that they would be they would become non-polar. So it's all about okay, how they come close to each other. So the polarity induced, initially they were non-polar, but afterwards polarity induced. That's why we can say that induced dipole, and this is weaker intermolecular force of attraction as compared to uh, permanent dipole. Okay.
Okay. Because it's temporary.
Yeah, exactly.
And sir, I have another doubt.
Hmm.
How do you think are they gonna how do you think they're gonna ask this question?
देखते हैं, पास पेपर करेंगे फिर बताऊंगा आपको मैं. फिलहाल तो लेट्स सी द कॉन्सेप्ट एंड व्हाट आर द फैक्टर्स ऑन व्हिच the temporary dipole depends. The intermolecular force depends. What are the factors? Remember, we have multiple factors in which you can see the first factor, number of electrons, in which the first factor is number of electrons. Okay, factors on which factors factors on which intermolecular force depends. Number one, we have number of electron. Number two, we have surface area. We have surface area. So, this is methane. This is ethane. Both are gases. Both are gases. How many electrons are there in methane? You know the proton number for carbon, that is 6. And you have 4 hydrogen atoms, that is total 10. 10 electrons. And if you have ethane, ethane means 2 carbon atoms, 12 electrons plus 6, that is 18. So more electron means more intermolecular force. Less electron means weak intermolecular force. That's why I am saying that it depends on the number of electron, and number of electrons are directly proportional to intermolecular force. Okay.
Sir, the strength is stronger or the number of the internuclear forces?
Strength of the intermolecular force would be stronger if
Okay.
you have more number of electron, और इसी तरह से if you have uh, less number of electrons, so means that the strength of intermolecular force would be lower.
Okay.
Okay, sir, but wouldn't the electrons repel each other if you have more electrons?
हाँ, वो मैं आपको बताता हूँ कि let's suppose I was giving you an example of chlorine. I was giving you an example of chlorine. Let's consider bromine. Let's consider bromine. So bromine means um, Br and Br. Of course, bromine ka proton number is higher than chlorine. Of course, chlorine is 17. Bromine is 35. Bromine ka proton number is higher. Okay, and when you have two molecules of bromine, just like that, and they are going to approach each other in this way. So 35 electrons, 35 electrons, 35 electrons, 35 electrons. In the case of chlorine, 17 electrons, 17 electrons, 17 electrons, 17 electrons. Um, when the chlorine is going to come close to each other, when the two molecules are going to come close to each other, as they have the less number of electron, it's just like a tiny magnet. It's a tiny magnet. Of course, when the size of magnet is smaller, so they are not going to repel in a stronger manner. Of course. So, but when the size of a magnet is bigger, they would be repelling each other with a greater strength, of course. So due to the greater force of
So are they
repulsion,
gonna have the induced dipole?
hmm, they are having the same
Aren't
induced dipole, but it's stronger. But the strength of intermolecular force would be stronger due to the greater force of repulsion, okay, they are having stronger stronger IMF, stronger intermolecular force. That's why I was saying, okay, more electron means stronger IMF, less electron means weaker IMF.
so,
Okay.
sir, लेकिन repulsions तो repel होते हैं ना? How are
हाँ,
you gonna
रिपल्शन
have stronger?
देखो जरा, chlorine, ClCl, and ClCl, partial negative,
सर अगर
partial
इनके पास भी
positive, partial negative,
ओके
partial positive. और
सेम
इसी
सेकंड ब्रो
तरह से if you have this bromine, if you have this bromine, partial
ओके
positive,
I
partial
understand now
negative, partial positive, partial negative. So they are having strong charges, strong
okay
charges. क्यों? Due to the, these charges are formed due to the stronger repulsion, and these charges are weak charges. You know, they are formed by the lower repulsion, weak repulsion. So due to the weaker repulsion, the smaller repulsion, the weaker charges are produced. And due to stronger repulsion, the strong charges are produced. When the
oh I
charges are
got it
stronger, they would be attracting in a stronger manner. So इसलिए मैं कह रहा हूँ कि they are having higher in you can say intermolecular force. Okay.
okay
So
thank you
the
sir
dipole is going to be stronger.
Yes, their boiling point is strong, higher. Their melting point is higher. They would be liquid at room temperature. Fluorine is a gas at room temperature due to the weaker intermolecular force. Why iodine is solid at room temperature? Due to the stronger intermolecular force, because iodine is having more number of electrons. So they would be having a strong repulsion. As a result of a strong repulsion, they would be having a stronger intermolecular force. That's the reason uska melting point is also higher, the boiling point is also higher, and not only this, it's solid at room temperature. Okay, it's solid at room temperature. Okay,
Yes, thank you. Yes.
okay
challenge. Then we have another factor that is known as surface area. Then we have another factor that is called surface area. सरफेस एरिया की जो टर्म है, mostly you will see in organic chemistry, mostly I mean, uh, let's suppose this is ethane, this is ethane, CH3, and this is butane, this is butane. Okay, this is butane. So the surface area is higher. So the surface area is higher. What do you mean by this? The surface area is higher. You can see this. Let's suppose I am considering the two layers. Let's suppose I am considering the two layers just like that. Let's suppose I am considering the two layers. Same goes for this. Same goes for this. Okay. Let's suppose when the two molecules are going to attach, when the two molecules are going to attach together, as you can see, so their attachment is 75% attached. They are 75% attached, more point of contact, more point of contact. Okay, and if you can see this molecule, if you can see this example in which you can see k 25% attachment, 25% attachment, you know, क्यों? कि the surface area is lower. Why? Because the surface area is lower. So of course, if the two things are going to attach in a greater manner, you can say the point of contacts are higher. So you cannot separate them together easily. You cannot separate them together easily. Okay. So that's why its intermolecular force would be higher, and this intermolecular force would be lower, and this intermolecular force would be lower. Okay, तो इसलिए surface area is also directly proportional to the number of to the intermolecular force. More surface area, stronger intermolecular force.
Sir, number
More
of
surface.
electrons and surface area are directly related, right? If the number of
Exactly.
electrons are more, the surface area is
हाँ हाँ
more.
हाँ exactly. More
NF more.
electrons, stronger intermolecular force. More surface area, stronger intermolecular force. Straight away, okay? Okay.
Yes, sir.
Then we
Okay, sir.
have hydrogen bonding. Then we have hydrogen bonding. So hydrogen bonding means it's the, you know, there are three intermolecular forces. Among these three, hydrogen bonding is the strongest. Among these three, hydrogen bonding is the strongest. Okay. So, and the temporary is the lowest. I'm talking about the strength of these forces. So temporary is in between hydrogen bonding and temporary dipole. So which is the strongest one? You will say hydrogen bonding. Which is the weakest? You will say temporary
Induced.
dipole. Okay. So
Temporary dipole.
induced dipole, or you can say London force, or you can say dispersion force. Hydrogen bond, it's also a type of intermolecular force, but this is something special. Like, in permanent dipole, the permanent dipole can be can exist with any of the molecule, between any of the molecule. Let's suppose you have HBr, HCl, HI, CH4, CH3, or C2H6, or H2SO4, HNO3, or ammonia, what, like everything. But hydrogen bonding is specific to some extent.
Sir, but
If you
the molecules have to be polar, right? If you have a permanent dipole.
polar, exactly. Like alcohol, carboxylic acid. Okay. So these molecules are polar, so you will see, okay, there would be permanent dipole. But in hydrogen bonding, if you have these three elements, phone, if you have phone, fluorine, oxygen, and nitrogen, if you have phone, then there would be hydrogen bonding, like between the HF, fluorine. Fluorine is a part of this phone. Fluorine is a part of this phone. Of course, this is going to have hydrogen bonding. And if this is Cl, it's a permanent dipole. It's not hydrogen bonding. So they are the same. They are the same, but we have specified the three elements: fluorine, oxygen, and nitrogen. They are having
So
highest electronegativities among all the elements. When you will see the table, when you will see the table for electronegativities, you will see among all the elements, these three elements is having highest electronegativities. So that's the reason, okay, I have selected these three, and then I'm saying that whenever you can see the force of attraction between these one, so you're not supposed to say that this is a simple permanent dipole, or like you can say that this is having hydrogen bonding due to these
so that means
higher
hydrogen
electronegativity
bonding
elements.
only occurs between fluorine, oxygen, and nitrogen, right?
Yes,
Only between
yes,
these. Okay.
only,
Any
only.
other molecule does not give us
And there is some
hydrogen bonding.
confusion, whenever we ask HF, we say, where is hydrogen bonding? Where is hydrogen bonding? You know, bit like, let's suppose you have HF. When we ask, where is hydrogen bonding? So they say, this is hydrogen bonding. No, this is covalent bond. Bhai, hydrogen bond is a intermolecular force. This is intermolecular force. ये intermolecular force थोड़ी है. This is covalent bond. This is simple covalent bond. This is simple covalent bond. Remember, if I'm going to give you the two molecules of HF, then you will see partial negative, partial positive, partial positive, partial negative. So then this is called hydrogen bonding. This is called hydrogen bonding. Okay, this is called hydrogen bonding. So this is confusion. Remember, okay. So hydrogen bond is a type of intermolecular force. It's not intramolecular. It's not intramolecular. So you have to take care it. You have to take care it.
Sir,
And
what's the difference between intra and intermolecular forces?
intra means between the two molecules. This is like intra, like the dotted lines are intra. and in the molecule is inter. Sorry, this line is intra, like in the molecule, and this dotted line is inter, between the molecule. That's the difference. Okay.
Sir, would there also be permanent dipole interactions happening?
They all are dipole attraction. Di means two pole, means charge. Di means
What?
two pole, means
So,
charge.
so we'd have permanent dipoles and hydrogen bonding and London forces?
No,
All
there is
three?
no any London force between this. Only you can say permanent dipole, but it is recommended that whenever you can see these three elements, any one of them, whenever you can see fluorine, oxygen, or nitrogen, so specifically you are supposed to say they are going to have hydrogen bonding rather than you are writing that they are going to have permanent dipole. Other than these elements like chlorine, phosphorus, sulfur, any other element you can say. Okay, you can see whenever, so then you are supposed to say that they are going to have permanent dipole. Okay.
Okay.
Sir, dipoles exist everywhere, right?
Yes,
Okay,
dipole
it's
exists
just
everywhere.
okay.
क्योंकि
So,
in a non-polar
सिर्फ
there would
direction
be
दिखाती है
temporary
dipole.
dipole. हाँ, सिर्फ interaction है. It's a simple interaction. Okay.
Okay. And
Yeah.
sometimes you have to show the which the side of the electronegativity, right? You have to point the arrow towards the more electronegative molecule, right?
हाँ, वो तो शो करने के लिए कि where the electron is going. Okay, वो तो ये शो करने के लिए. Okay.
Okay.
Yeah. Why H2O is liquid at room temperature? Why? Why H2O is liquid at room temperature and H2S is a gas? Why H2O is liquid at room temperature and H2S is a gas? So, can you explain it? Why this is so?
Is it to do with high latent heat, energy of vaporization for water?
Oh, okay. Or.
H2 has hydrogen bonding, but H2S doesn't have.
Yeah.
It has
That's the
permanent
main
dipole.
point. Ke hydrogen bonding, whenever you can see hydrogen bonding, so the boiling point would be higher. In water, there is hydrogen bonding. In H2S, there is no hydrogen bonding. Simple. Simple. It's very
So
simple.
permanent dipole.
Yeah, permanent dipole. So category, if you can see the category, hydrogen bonding is at the top. So if you can see hydrogen bonding, so the boiling point would be higher. So that's why I'm saying H2O is going to have higher boiling point. So their particles are going to close together as compared to H2S due to the greater force of attraction. So that's why I'm saying, okay, this is liquid at room temperature. This is gas at room temperature. Okay, easy, है? इजी है, मसला नहीं है कोई. Okay. Or if you have hydrogen bonding, then what would be the effect on that molecule? The density increases, the solubility increases, the boiling point increases. This is the characteristic of hydrogen bonding. This is the characteristic of hydrogen bonding. If you have hydrogen bonding, due to the presence of hydrogen bonding, the solubility, okay, the solubility and melting and boiling point drastically increases, when there is hydrogen bond. And when there is no hydrogen bond, so all the things are at normal state, nothing is new. Okay, so hydrogen bond is special. It's going to increase the melting and boiling point and also the solubility of a substance.
Sir, it says the molecules are attracted together due to opposite charge and lone pairs of fluorine. How does that make sense? How is
uh
lone pair?
Lone pair of fluorine, yes, of course, whenever you have, let's suppose in alcohols, you can see only one oxygen. And in carboxylic acid, you can see there are two oxygen atoms. The boiling points of carboxylic acids are higher. If you ask why, because carboxylic acids can make two hydrogen bonds. And alcohol can make only one hydrogen bond. So that's why carboxylic acids are going to have higher boiling point due to the more हाइड्रोजन बॉन्ड्स। तो ये भी डिपेंड करता है कि हाउ मेनी हाइड्रोजन बॉन्ड दे आर गोइंग टू फॉर्म, हाउ मेनी हाइड्रोजन बॉन्ड्स दे आर गोइंग टू फॉर्म। ओके, सेट।
Okay, sir.
Then we have, they have mentioned in your specification that they are saying be able to predict the presence of hydrogen bonding in molecules analogous to those in method in 7.2. Like, if you are only considering that hydrogen bond is present between the molecules only, no. You have to see ke fluorine and nitrogen as well, like in ammonia.
Sir, can you repeat what
Like
you just said?
hydrogen bond is present in water, in ammonia, or in HF. Basically, I'm targeting these three elements, 1, 2, and then 3. If you can see in any of the compound, so then there would be hydrogen bonding. So mostly ये हो रहा होता है ना कि we are thinking that के only the hydrogen bond is present between the water molecule. No, it may be between the ammonia and it may be between HF as well. Okay, we have to focus on these three elements: fluorine, oxygen, and nitrogen. Okay, are you getting my point? Easy है? Okay, आगे चलो.
Yes, sir. Yes, sir.
Okay.
Okay, sir.
Okay. Or do you know the term volatility? Volatility. Do you know the term volatility?
Yes.
What is this?
It's how easily like a liquid or substance gonna like evaporate.
Good. Good. So hydrogen bond is the stronger intermolecular force. When there is a stronger intermolecular force, when there is stronger intermolecular force, so the thing would be less volatile. It's not going to evaporate. Why? Because the attraction is higher. Because the attraction is higher. And if you can see, there is a weak intermolecular force. So I can say it would be more volatile. It would be more volatile. Okay. It would be more volatile. Remember, would be more volatile. Okay.
So can you repeat that
Sir,
again?
why would solubility increase in a hydrogen bond?
Oh, sorry.
What?
Why does solubility
Increases.
increase in a hydrogen bond?
Oh, okay. Let's suppose this is sodium chloride. Okay. Negative and positive. And this is the water molecule. Okay. Uh, all are polar. Okay. All are polar. I have dissolved sodium chloride in water. So the sodium chloride is going to, like, the water molecules are going to approach the sodium chloride. So what would happen? This chlorine would be attracted by this water molecule, just like that. And this would be attracted by this water molecule, just like that. So these water molecules have separated the two ions. These water molecules have separated the two ions. You know why? Due to the stronger partial charges. Due to the stronger partial charges. So let's suppose you are going to dissolve sodium chloride in that solvent who has weaker partial charges. So how can you expect that this species is going to attract this and they would be reacting together? So it depends. Okay, how much is stronger, like how much polar is this? If this is more polar, stronger charges, so it has an ability to attract this chlorine, and of course the compound is going to break down. So completely it is depending upon who is coming to attract. Who is coming to attract? The one which is going to have a lower attraction? So no, they are not going to separate them together. Of course, when they are not going to separate them together, so means they would be insoluble. Kaise? If you remember, when something is going to dissolve in water, we generally say that it is broken down into ions. And when something is not going to break down, so of course, how can we say that the species is soluble in water? So to break it down, you need someone else. You need some source who is going to break them down. So the source is that water. So the water is going to have hydrogen bonding, means that they are going to have stronger charges. So they have a greater ability to attract this chloride and this sodium, and due to this, so they would be, you can be separating together, or of course, they would be soluble in water. Are you getting my point?
What do you mean by stronger charge?
Sorry?
What do you mean by stronger charge when you say for the
Uh,
water?
Due to the difference in electronegativity, okay, oxygen is the highest electronegative one. So that's the reason oxygen is going to have a stronger partial negative charge as compared to Br, as compared to this one. So of course, if you are going to dissolve your sodium chloride in this HBr, so this positive charge is not going to separate it. It's not going to attract this chloride. It does not have any ability to attract this because due to the weaker partial charge. Okay. Let's suppose you want to separate the two friends, like you can say you want to separate the two friends, okay, who are going to have a friendship since the 10 years. You cannot do this. Okay, you need very strong attraction to separate them together. You need a very strong attraction. So you need something that is going to have a stronger partial charges, and that is only present in that molecule which is going to have hydrogen bonding, because hydrogen bonding is at the top. It's the strongest intermolecular force of attraction. So that's the reason water is a universal solvent. 99% compounds, they are soluble in water. Rest of the compounds, if you can see that this is not going to have a good solubility in that water, so you can use another solvent, like you can see any other organic solvent. But right now we are only discussing the effect of hydrogen bonding on the solubility. So this is how. Okay. इब्राहिम समझ आ रही है मेरी बात क्या कह रहा हूँ मैं इब्राहिम अब्दुल्ला
सर सो इंक्रीज हो जाएगा हाइड्रोजन बॉन्डिंग की वजह से
हाँ ना दैट्स द रीजन
अच्छा
ओके
ओके सर
तो क्योंकि it has a higher ability to attract.
Sure, because it's hydrogen bonding. That's why,
Yeah,
or because of the partial positive, partial negative charge.
same thing. Hydrogen bond है तो strong partial charges है, of course.
तो इसलिए ये easily
Break
क्लोरीन
down.
को attract करता है.
Yeah, exactly.
And
Okay.
और हाइड्रोजन ब्रोमाइन तो वो नहीं है ना,
No, 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 no,
हाइड्रोजन बॉन्डिंग.
no, no, no. Hydrogen bromide नहीं है. No.
ओके, तो इसलिए ये वीक है और ये नहीं कर सकता अट्रैक्ट क्लोरीन को,
Exactly,
हाइड्रोजन.
exactly, exactly.
ओके.
Sir, do we need to know about enthalpy of hydration,
No.
or we don't need to know? Okay.
No, no. वो तो अलग है बिल्कुल ही. It's not a part of this. Okay.
Sir, the way I learned solubility was by looking at the sizes of the atom or element. If like hydrogen is small and bromine is bigger, so it's gonna be easily soluble. It's gonna dissolve more easily.
In terms of energy,
So
अगर तुम बात करो तो देखो
still-
we have multiple ways to, you know, basically in this chapter, this is purely intermolecular force of attraction. We are only going to learn okay, like then what are the factors on which the IMF depends and how many IMF you have, and you have to define each and everything. That's it. So the solubility is depending upon, whenever we discuss hydrogen bonding, then we have to discuss okay, what is the characteristic of that hydrogen bonding. You are saying that this is the strongest one. So of course you are supposed to say, okay, if this is the strongest one, so what would be the characteristics? So that then we say, okay, if some molecule is going to have hydrogen bonding, so their density would be higher, their boil point would be higher, their melting point would be higher, their solubility would be higher. That's it. Okay. Set हो गया?
Okay.
Good है? चलो जी. Okay. Okay. Then we are
Brilliant.
going to have some topical papers on intermolecular force of attraction.